Here we have the power system for the Smart Arm. Right here it consists of 4 AGM high capacity 12 volt batteries. Those then tie in to a battery monitoring system which measures the current through this device and measures the voltage which are displayed on our screen. We have a 12 volt inverter to 120 volts which powers the printer. We have the remote control for the remote control, and this is the receiver, and this of course is the transmitter for that remote control. The signal gets out of this metal box by going through this wire out to an antenna right here, and that consists of the power system for the Smart Arm.
Here we have our equipment box. Inside here we have our wireless printer, which can print on 8.5 by 11 and wide format 11 by 17, which is great for printing out drawings. We also have a 10 terabyte hard drive, which is used to store information from the tablet as well as drone footage. We also have a Mavic 2 Enterprise by DJI. The drone is capable of sending video via cell phone, streaming to any device over the internet.
Here we have the heart of the communication system, which consists of a Sierra module, which gives us both cellular and Wi-Fi connections. As you can see on here, we have 3 Wi-Fi connections to provide us a local area network that is central to this unit. And then we have 2 cellular connections on different servers, and they have different IP addresses for each one, so that if Verizon goes down, for instance, we still have AT&T connections. We have LEDs down here that indicate that the power is on, You can see communications going back and forth, signal strength, Wi-Fi connection, antenna connection, and another Wi-Fi connection. These all communicate together on a 24-volt system and go out through these cables and connect down here. And then we have on the outside, we have all 5 antennas, the 3 Wi-Fi antennas and the 2 cellular antennas. And around the outside we have blue beacons, so that when the mast is up, you can actually get to see this from quite a distance. And of course we have floodlights so that we can light the area at nighttime if there's an incident or if we need extra lighting.
This is the HMI, Human Machine Interface, which has been pre-programmed for the Smart Arm. The 2 soft buttons for the beam move the beam out 90 degrees horizontally, and then the light pattern is chosen. After the event, the beam then is retracted back into its housing. The mast moves the antenna and lights and camera up 90 degrees, and after the event, the mast is then retracted back down. A stop button stops both the beam and mast in its position. 4 light patterns on the beam begin with a red flashing stop light. Then, when traffic is allowed to move across the beam, a left arrow pattern is set. To direct traffic in the opposite direction, a right arrow sequence is chosen. Then, if both directions are desired, cross arrows are projected on the beam. An off button shuts any of the light patterns instantly. On top of the mast, 4 blue beacon lights alternate to show that the system is operable. Below the mast are floodlights which allow for work during the evening. The 2 hurricane locks are used to lock the beam either in the deployed or stowed position during a heavy storm. The call home button is used to call a single recorded line that alerts the receiver to contact the system for 2-way communication. The battery indicators display the level of charge for the battery set as well as the current draw from both volts and amps. The display shows camera 1 in 4 selectable positions. The second display, also mounted inside the control box, is a PC tablet that has customized icons that control cameras, drones, as well as the ability to view documents and to print them from an onboard printer, as well as engineering software that can read SolidWorks. Lastly, a slew of communication devices that allow the system to view video, receive text, voice, and data. Lastly, a pod soft button which receives a message that is directed from a supervisor to the Smart Arm unit. The pod can be video, voice, data, and text, and can be downloaded by a worker at the site. In addition, the pod can be uploaded by the worker back to the supervisor for ultimate communications.
We just received word that our project manager has sent us a new marked up drawing via email. So we're going to access our email. And download the drawing that they sent. And now I'm going to print it to our wireless printer.
Take off.
Good morning, this is John Tompkins. I'm the design engineer for this project, sending this information in remotely. You should have a copy of this plan sheet here that you can download, as well as a product information sheet on the 18-inch RCP pipe that we're going to be installing today. Each one of these sections will weigh 168 pounds per linear foot, which is roughly 1,260 pounds per section. We're going to be working going from this existing culvert on this side to the existing culvert on the opposite side, connecting each of these sections as we go across. At each location, when we butt up to the existing culvert, take non-shrink grout and seal each of those connections in on each end, and continue to work your way across from end to end. When you get to the far side, starting from one side working over to the other, cut the existing RCP section to a section that'll fit in there, and seal each side with non-shrink grout. At the end of the day, just be sure you backfill everything with native material and lock the pipe in place. Should be a fairly easy project, and if you have any questions, don't hesitate to contact me. And also, there are also specifications downloaded as well for additional information.
Dave, you're doing this. Is this enough light to work?
Yeah.
Okay. And now the beacon.